two cyclists are at the same road intersection, and one cyclist travels north at 20 kilometers per hour, and the other travels west at 15 kilometers per hour. So let's try and represent this in a diagram. So suppose this is the intersection, and it's given that one cyclist travels north at 20 kilometers per hour. So let's just call that Y. And then the other one travels west at 15 kilometers per hour. Let's just call this X. And assuming that at any time t, the distance between them is given by z. So the question is, we are required to use calculus to show that the rate at which the distance between the two cyclists changes is independent of time. So basically, we are required to show that dz over dt is constant, which means it's independent of time. Okay, so what are we given in this question? So in terms of what we've learned in terms of rates of change, we are given the following. So we are given the following information. So the first thing that you're given is the rate at which, the speed at which one cyclist is traveling north. So that can be expressed as dy over dt, which is 20. And the second cyclist is traveling west, and that will be dx over dt, which is equals to 15. So what is required? So we can write here what is required is dz over dt. So that's what you're looking for. And you want to show that dz over dt is a constant. It's independent of time. So what's the relationship between x, y, and z? So we can see that the relationship between x, y, and z, so the relationship between x, y, and z is that x squared plus y squared is equals to z squared. And what we want to do here is we plan to use this relationship to guide us on what we need to do. So let's assume that after some arbitrary time t, yeah, after some arbitrary time t, this cyclists are somewhere, and what we want to do is to find the distance between these two cyclists after time t. So so after some time t, x will be equal to, now we know that distance is equals to speed times time. So after time t, this cyclist who's traveling west would have gone 15t kilometers. Yeah, so x will be equals to 15t, and y, so this cyclist who's traveling north would have gone 20t kilometers, which implies that using this relationship here, which is a Pythagorean relationship anyway, so z will be equal to the square root of 15t squared, because you want to find that distance in terms of t. So 15t squared plus 20t squared, and that will be equal to the square root of 225 t squared plus 400 t squared, which is the square root of 625 t squared, which is just 25t. So after time t, x is given by that, y is given by that, and z is given by 25t. So let me just, highlight those because we plan to use them. All right, so the next step is we want the rate of change. And because we have this relationship between x, y, and z, the plan is to differentiate this equation implicitly so that we can be able to find the z over dt. So if we differentiate this implicitly, we'll have derivative, and we are differentiating with respect to t. So d over dt of x squared plus d over dt of y squared will be equal to d over dt of z squared. Okay, so one thing is that because you're differentiating with respect to t, here we'll have to be forced to use chain rule. So derivative of this squared, a function squared, will mean that we'll have 2x. Now the d over dt of x will be dx over dt. And the same thing applies here. So we'll have 2y dy over dt. And here, same thing, 2z dz over dt. Now, if we cancel out, the 2's, then we'll end up with this relationship here. We'll end up with x dx over dt plus y dy over dt will be equal to z dz over dt. Now, what you're interested in here is this. We want dz over dt. But, looking at this question, we are given dx over dt, which is 15. We have x, which is 15t. We have y, which is 20t. dy over dt is 15. And z is 25t. So what you're going to do next is to substitute all those into this equation. So we'll end up with 15 multiplied by 15t plus 20t multiplied by 20 will be equal to 25t multiplied by the z over dt. So this will be equal to 225t plus 400t, which will be equal to 25t dz over dt. Now, if you add these two, you'll end up with 625t being equal to 25t dz over dt. So that implies that dz over dt will be equal to just 625t over 25t, which is just 25. And because this is a constant, as you can see, because it's a constant, it means it's not dependent on time. It's a constant, hence not dependent or not time dependent. It's not time dependent. And that's basically what you're trying to do here. We are trying to show that the distance between the two cyclists is independent whatever the rate of change at which the distance between the two cycles is changing is independent of time. And that's basically what's happening here. You can see that that rate of change is a constant and it's not time dependent.